So, COD-like season 2. Now, actually, we're going to start entirely from scratch. And the reason for that is we're going to edit so much both the controller and other things, including the multiplayer part and all these things, that it will actually make it much more easier to begin from scratch. Okay, don't worry if you feel like you're missing the progress you did from the last part. Trust me, this will be much faster and this will be much better in many terms. So, let's get started. We just have an empty scene. I'm not going to bother importing any art assets right now because there's no need. We're just going to create and go along through the way. We'll do a lot of things and then we'll either add some assets later. So on the first part, let's just recreate our movement with the FPS controller. So our setup is we have one game object, our controller. It does have a character controller in. Only thing that you have to do, or let's actually do it from the start. Okay, our character controller, you see it's down on the ground, raise it up to 1. That's all you need to do. And our main camera is about 1.8 on the height. So let's get started into writing our controller. First of all, let's create the controller script. Or if you want to you can make it as character controller. Actually, character controller already exists, so you probably want to name it something else. Anyway, it doesn't matter. So let's add our namespace always, and then on start we're going to, of course, need reference to the character controller, which I'm just going to call C, and we'll do get component. Considering although it's on the same game object, it should be fine. So we have our controller and we're going to be moving versus with our controller. We're going to pass an input vector and then on update from that input vector, we're going to be creating a velocity. So on update, we'll do an input velocity, a new method, a new variable, and we're basically going to get our forward vector multiplied by anything we pass on the input on the y. Now we could make this into a vector 2 actually, since there is no z value into this, and because we also want to be moving left and right, we're going to add transform.right multiplied by input x. Okay, then just applying this to our controller will actually make us move, to be honest, but of course that will be a really basic move, so we're not just here for the basic things. So we should be getting this, we should be storing this actually into a target velocity, which we're going to then to be taking our input velocity as this, multiplying that with time.delta time. Now I'm sure this isn't the first time you see me do this, but I'm casting on each frame, I'm casting the delta at the start of the update, so we don't have to be calling time.delta time all the time. So we also need to be able to control how fast we move, so we're going to assign a move speed over here. So we can just do move speed by delta. Okay, then applying that as target velocity. Okay, then we're actually just, before we even do inputs or anything, we could just try this as it is. I'm just going to put the game view down there and just assign the controller. Okay, so hit play, and just setting this to 1, you will see we're actually moving. Perfect. So we have our controller, but we also want to, of course, use inputs. Now I'm going to create an input manager, or you know what, let's call it FPS handler, because even though it's the inputs, it's an FPS game, so everything is going to be coming from the FPS handler. So delete all this. Now I'm not going to use my own update because the controller will be responsible from updating the FPS handler, and also the FPS handler will have to be only on the local player will be ticking the FPS handler. The client players of course will be in TPS mode or third person view mode, so I guess you can say like that. So what we need to be doing here, first of all, we should assign the camera transform. Okay, and then we should be passing also the controller. So now we have access to the controller right away. So let's do the easy things first. We're going to create an input vector, and for that let's start with 0, or you could just directly assign on the input vector of our controller. For now we'll use get axis vertical and input dot x input get axis horizontal. Later down in the series we're going to change this to the new input system, but for this it will work fine. And now if we assign an FPS handler over here, let's call it this, and before we create of course our vectors, if we do FPS handler.tick, we can pass the delta, and this we will be able to use this and move around with only the with the keys basically. We can test it out if you want, but let me assure you, we forgot to assign the FPS handler. Now let's assign also the main camera, but it will work fine. Okay, so now we can move fine just with the keys. So let's put in the camera as well. So for our camera we need a new vector to import, and this will be our camera input. Okay, now I'm actually just going to move the camera transform back to the original controller. Just you know what, no, we'll keep it here, and I'm actually going to okay, so the thing is the controller needs to know our camera input because it's going to be rotating us, I guess, but okay, we'll keep this then for the controller. Then in here we'll do camera input dot y input get axis mouse y, and c dot camera input dot x input get axis mouse x. I think there is a space in there. So under update, I think we should just split this to handle movement, float delta, and to handle rotation, float delta. So let's get all this, paste this in here, then handle movement and handle rotation, I guess, handle movement and delta. So for handle rotation, things are very simple. All we have to do for the rotation, for the Y rotation, so basically left and right, all you need to do is transform.rotate up multiplied by camera input dot x by a rotate speed. Let's assign the rotate speed. I'll leave it to 1 or maybe 3, and we'll see how much we need to change it. So transform.rotate speed, and then for the camera transform, we're just going to rotate on the right axis now by camera input dot y multiplied by rotate speed and space dot self. So we are rotating in local space. Now we need to make the camera input negative, so when we're moving the mouse up, we're actually moving up, and when we're moving down, we're moving down. If you want to inverse controls, then just simply change this. Okay, so to save, and let's test this out, and we should be able to, when we assign the camera, we should be able to rotate anywhere we want. Okay, 3 is too slow, so 8 is fine. Now, two things that we have to do, and which are nice to have actually, is we should always assign a target frame rate, just so, because our camera could move faster and it might seem like twitching, but it's actually working perfectly. So that's not usually where you want to place the application, the target frame rate, but for now, because there's only one script in our game, or well, two, I'm just going to place it here. Later on we'll move it to the game manager. Now let's say we want to add jump, because you know jump is kind of important in some games. So how do we do this? First of all, we need to know if we want to have jump input. So I'm going to do public void try jump. The first thing we need to know is if our controller is grounded or not. So if you're not grounded, then that means that your target velocity will actually change depending on your jump. So let's see how we do this, and hold on. So if you're not grounded, we'll do a return. Then we need to assign a variable that is going to keep track of our vertical velocity. We also need a float to know how high we can jump, so that will be jump height. And we also need to set up a terminal velocity, because otherwise we could be flying off. Okay, so when we're trying to jump, how do we find how high we need to jump? So we can set up a vertical velocity to be squared value of our jump height multiplied by -2 by physics.gravity.y. And I think vertical velocity is it's actually a float, not a vector. So that's our vertical velocity. So what do we do with our vertical velocity? On our basic velocity, on our base velocity, we're going to be adding on the y, I think. Well, first of all, we need to be checking if our vertical velocity is less than our terminal velocity. So if it is less, then we're going to be adding physics.gravity.y multiplied by delta. Okay, then on our target velocity, we're going to be adding vector 3 dot up by vertical velocity by delta. Okay, so this will assign the vertical velocity to our target velocity. So basically, whenever we call this, we're going to be calculating our jump height. I think this is just from the scene. Yeah, I don't remember where I got this from, but it works, to be honest. If you Google it, you should be able to get a result if you need to dig into that deep, but I think it's just, yeah, you can just do this and it will work fine. So let's test this. Then on the FPS handler, we could just do if input dot, let's do get button down, jump. I think there's a jump already set. C dot controller dot try jump. Okay, let's test this out. And jump terminal velocity, let's set this to 8, jump height to 2. Okay, and you can see that we're normally jumping. Now, one problem. I'm going to jump. Well, actually, it will make a little bit more sense if we do it a different way. So, over here, I'm going to add a trail renderer. Or maybe I'm going to add the trail renderer on my camera. And let's make this lower. Just so we see how the trail works. So I kind of want to jump. I think we forgot to reassign the terminal velocity. Set that to 8. So I'm moving and I'm jumping, as you can see. So now I want to go and jump and fall down, so we see, and stop pressing any inputs, so we see what's actually going to happen with our velocity. Okay, some games do have this, but we want to keep momentum. Okay, so our game, we kind of want to keep moving forward. We don't want to just jump straight down. So what we need to do is, first of all, stop applying the target velocity of our input if we're not grounded. And if we are grounded, so if C dot is grounded, and an else. So basically what's happening on our target velocity, and actually I'm going to add this here before we add the vertical velocity, because we might have vertical velocity to add to. And I'm going to keep track of my velocity, which I'm going to call momentum. Okay, so whenever I'm grounded, I'm going to be keeping track of my target velocity. Whenever I'm not grounded, then our target velocity will be overridden by our momentum. Let's set up the 8 here as well, and let's go and test this out. So I'm going to jump and stop pressing anything, and as you can see, we now have actual momentum. And the same goes now when I'm jump, I don't actually have any control over it. So let's say we want to add some control over it. How do we do that? First of all, let's split the move speed to air speed. Let's say 3. So after we assign our momentum or target velocity, we could be adding back the input vector without, however, the move speed. We now want, oops, that's after we send it, momentum with airspeed. Okay, so let's test this. Of course, we want this to be less movement, so let's go. Oops, wrong way. Now you can see that I'm actually able to move. And oops, hold on. Target velocity, we multiply that by air tail speed. Now this is input velocity by airspeed. Yeah, otherwise it's just the airspeed by the momentum you already have. You don't want that. It will have closed this. We're just going to be adding velocity. And yeah, now it works fine. Let's go the other way so you can see it. You can see that I have control actually in my jumps. So that's basically our controller. If you want to go on the FPS handler, for example, because we know only the local player will have enabled the FPS handler, we could just say controller init here, and then I'm going to pass the initialization at least. I'd still not do it here. Application target frame will only set up in when we start the game, don't think, or in the options scene. And since we are here, we could do cursor lock mode, cursor dot lock state equals cursor mode dot locked, and that's it. We will also be having player, but I'll also do FPS handler dot init this. Okay, so there we go. We now have a base for not just an FPS. You can actually use this for anything you like. Even a third-person shooter will still use the same values as we all do. Now, there's one small thing that is happening, but we can fix that on the second frame. But you can see bunny hopping actually works as well. But it does have a limit. Okay, awesome. So let's leave this as this, and then on the next part we're going to add some shooting back and so on and so on. So I'll see you on the next part.